All right, folks, we're going to start 3-2 today, which hopefully yesterday we picked up the idea that it was just mainly vocabulary, and that was the homework was basically targeting. And for the mere fact of what we're going to talk about today and the next day and the next day is going to use those terms. So we have to be on the same page of, what are we talking about? And you're going to find out as we move on in other chapters, the first couple sections of every chapter is going to basically be laying out terms for us, okay? So that we can have that discussion then later on in the chapter about what those objects have in regards to relationships with one another. So today we're talking about properties of parallel lines. Collectively, it's not that terrible, okay? And you probably can already maybe start justifying some of the stuff, or maybe you've even already seen this in other classes. But we're going to talk about this postulate today for the most part, and how that then generates three other statements for us, okay? But everything that we talk about today abides by that green phrase there, okay? Because these things are only said to be true if we know that the lines start off as parallel lines. Every one of our statements today, we're going to come up with one postulate and three theorems. I'm going to show you how to write them a little bit more concisely so we don't have to write three things down or four things total down. But all of them are going to start off with that phrase. Okay? If that blue phrase is not happening in front of me for my particular problem or for your particular problem, you can't make a conclusion about anything. Okay? So in this case, if I didn't have parallel lines, I would not know whether 4 and 5 are supplementary or not. Okay? They could be, they might not be. We don't know. Okay? You have to remember from chapter 2, we talk about conditional statements. We have to have our problem modeling what the blue statement is saying. That's the law of detachment. Okay? In order for you to be able to make a conclusion off of your problem, it needs to match some hypothesis, okay? And those hypotheses are going to be inside our theorems and our postulates and those types of statements. It says if that's happening, if you got parallel lines in front of you, then same side interior angles are supplementary. So the same side interior angles that we want to talk about then are 3 and 6. And 4 and 5. Okay? 3 and 6 and 4 and 5, they end up being supplementary angles. Okay? Now, likewise, 4 and 3 are supplementary as well, are they not? But that was already a fact that we knew, correct? Those are a linear pair. Okay? So this is new information now that we are going to be able to apply and use. Okay? But this is a postulate, which means we can't prove it, okay, but we can justify it. And I've created a GeoGebra, if I can find where I put it. There it is. And this is on my website, so if you ever want this GeoGebra, and any GeoGebra that I show you for the most part, I have linked to my website. So you can kind of mess around with this if you want to. But all I've done is I've created two parallel lines. And you can move these around. Okay, so you can create any set of parallel lines that you want. Okay. Now, obviously, this is only going to work if they are intersecting this transversal. And you can move that transversal to anywhere you want. Okay. I've got this line S, this line M, and my transversal T. And you can actually, grab T and move it around as well. Okay, but we've got these check boxes on the left-hand side that we can click and maybe see some relationships. So the first one I'm going to click here is just to show a pair of same-side interior angles. So hopefully this, if you're going to use this applet, it gives you an idea of where you can recognize and maybe kind of declutter things. So you can say, okay, now I know if those are same-side interiors and I start moving things around. Now, why did they disappear? Because now I don't have a line intersecting, right? A transversal's not intersecting, but now I can move them around, and I can justify that no matter how I move those, I now know that those are same side interior angles, and they're always going to be same side interior angles. Okay? If I click on the other set, okay, you see here that little red line on the left-hand side shows up. Okay? That's just a tool that allows us to slide things. Okay? So I want to prove to you why we know they're supplementary. Okay? And I guess try to convince you. This isn't a proof because it's a postulate. I want to convince you on why they're supplementary. If I take that line, that angle that is purple, will it slide and fit right there? That makes sense? So that purple angle is the same as that dark red angle. Okay, or more red angle, I guess, than I don't know if I can change that color and make it go back to purple. I can't. But that angle right there is the same as that one. So what do you know then about this series of red angles? They should be what to one another? They're supplementary, right? Why are they supplementary, though? Well, they add up to 180. That's what we get when we say they're supplementary, but they're a linear pair, right? The linear pair tells me that they add up to 180. So if those in that positioning add up to 180, but that red angle is the same as that purple one, then in that position, shouldn't the purple one and the blue one add up to 180? That kind of makes sense? Okay? So that's the justification of why same-side interior angles are supplementary. Okay? Now, the way I remember this when I was learning it at your age, I always try to, because I thought some of this stuff was hard, I try to figure out like easy ways to remember things. So same-side supplementary. Okay? Same-side supplementary. What is that in English? What kind of phrase is that in English class? Same-side supplementary. Sally sells seashells by the seashore. It's an alliteration, right? So same-side supplementary might help you because it's a special relationship that only exists in all the angles that we talk about today. Same side are going to be supplementary. All the other angles are going to actually be congruent. Okay, all the other groupings that we talk about today are congruent. So this is going to be a little bit of a unique one. So I remember that same-side supplementary idea to shed light on its uniqueness. Okay, just kind of going back. We'll do this example first, and then go back to the power, or go back to the GeoGebra. What this question says is, just zoom in and make it a little bit easier for me to draw on. It just says that angle 3 is 55 degrees. And then it asks you to identify what other angles are supplementary to angle 3. So if I look at angle 3, and we said 55 degrees. Okay? Give me an angle that is supplementary to it. Okay, 6. I would agree with that. Okay? But how do you go from 3 to 6? You're right. Would 3 and 8 be supplementary? Those are same side interior, right? So this would be 125. So same side interior are supplementary. And then if I look at 8 compared to 6, they are what kind of angles going on? Vertical. So doesn't 6 have to be the same as number 8 was? So 6 has got to be 125. So you're absolutely right that 3 and 6 are supplementary. Okay? 3 and what other angle are supplementary? 4. 3 and 4. Okay? 3 and 4 are supplementary because they are a linear pair. Good. They create that line right there. Okay? Their non-common sides create a straight angle. What other angle for the same reason is 3 supplementary to? 2, right? Are angle 2 and angle 4 also vertical? And do we find out that based off what we knew about them being supplementary, their vertical relationship exists as it should? And that's the idea that, you found angle 2 to be 125 because it was supplementary to 3. So that shouldn't contradict the fact that it is also vertical to 4, and that should be 125 because it's vertical to 4. Okay, so we got multiple reasons maybe why angle 2 is 125. We have, again, multiple reasons why maybe angle 1 is 55. It's vertical with 3. but it's supplementary with 4. It's supplementary with 2 as well, or linear pairs with those two things. So we've got 3, after we fill in enough stuff, we've got 3 reasons why angle 1 is 55 degrees. And any one of those reasons should not contradict or negate one of the other 3 reasons. What's angle 5 going to be? 55. What's angle 7 going to be? 55, okay. If I ask you to name, based on a vocabulary word, categorize or identify what types of angles 1 and 5 would be, what would you call those based off of yesterday's vocabulary? Corresponding, good. What do you see here? If the lines are parallel, what do you see about those 2 corresponding angles? They're both 55. They're both 55. They're congruent, aren't they? What do you see about those blue corresponding angles? Are they both 125? Are they congruent? What about angle 2? What would correspond to angle 2? 6. Are they both 125? Do 3 and 7 correspond? Are they both 55? So every time we see a series or a set of corresponding angles, when the lines are parallel, what do you think the conclusion is that we can make about those corresponding angles? They're congruent. Okay? Now, I don't think I said this. A notation to tell us that something is, or that lines are parallel is that arrow and that arrow. We put little arrows inside our lines that are on the interior of our lines, and it's just going to be, we put slashes to show congruency. We put those arrows on the inside of our lines to show parallel. Now, if those, just want to make sure we understand this. If I did something like that, oh, not like that. Okay, these arrows do not indicate parallelism. Does that make sense? Those arrows just indicate that the line's going on forever. Okay, it's the arrows that we put on the interior, right there and right there, that indicate that they are parallel. Okay, what about angles 1 and 7? What would you call those from yesterday's vocabulary? Alternate exterior. What do you see about their values? They're the same. What about that one there and that one there? Alternate exterior. What do you see about their values? They're the same. So what do you think you're going to say about this stuff? Alternate exterior angles are congruent. Okay, if the lines are parallel. Now, we're only making this argument based on angle 3 being 55. In order to say that alternate exterior angles are always congruent, I have to check that with 54 degrees and go through all that process. And I have to check it with 53 degrees, and then 50 degrees, and then 55.123 degrees. And I have to do it with an infinite number of numbers, which doesn't make sense, okay, in regards to being efficient. And I would never be able to finish that. I would die doing that, okay, because of all the things I had to check. So we're going to prove that here in a little bit and kind of maybe give you an appreciation for what a proof is really for. What are those angles? Those pink ones. Alternate interior. What do we see the relationship between? They're the same. They're congruent. What about 2 and 8? Same. Alternate interior again. Okay, so we're going to have an alternate interior angles idea. Alternate interior angles are congruent. Now, if we go back to this will allow you to see those things. Okay, so alternate interior, basically what happens is that we slide that angle. We said corresponding angles were congruent, right? We'll slide that angle, so those 2 angles need to be congruent there. And if I rotate that around, aren't these two up here vertical now? That makes sense? Okay, so we can see then that those two angles, when I take that one, cut it out or whatever, slide it up here, it should match exactly that one. So alternate interior angles are congruent. We do the same thing with alternate exterior. Okay. You see if that yellow angle slides and rotates to match up to that one there. So alternate exterior angles are congruent. Corresponding is a pretty easy one. Okay, we just see that slide that way. Let's write this statement down here. This is, so you already told me that alternate interior angles are congruent. This is the theorem that encapsulates that idea. Okay, but remember, because I'm going to ask this question on a test, I'm going to say, all alternate interior angles are congruent, true or false? And the answer to that would be false. Okay? Because I said nothing about the lines that make those alternate interior angles. For instance, yesterday, the picture we were seeing yesterday was something like this, right? That angle right there and that angle right there are alternate interior. But because the two lines that are getting cut by the transversal are not parallel, I can't make the conclusion of congruency with those. Does that make sense? Okay. So in order to make the argument that alternate interior angles are congruent, I have to first know that I have parallel lines. That has to be the condition. That's the law of detachment. We have to know our problem we're working on matches that hypothesis. Okay, so we have, that's the alternate interior angle theorem. And if we go through the rest of this PowerPoint, guys, there's a box that says alternate exterior angle theorem. There's a box that says corresponding angle theorem. Basically what I want you guys to do here is write that this is true, but then underline the alternate interior angles phrase and maybe draw like an arrow to it and say, we can put exterior angles there, alternate exterior, and we can put corresponding angles there, and still have a true statement. Does that make sense? And that will allow you to really write 3 theorems using just that one statement. Okay? If you want to write this, if a transversal intersects 2 parallel lines, then alternate interior angles, comma, alternate exterior angles, comma, corresponding angles are congruent, that's fine as well. I mean, that encapsulates all 3 of those ideas together. So we have 4 groupings of angles. We have alternate interior, alternate exterior, corresponding, and then same side interior, right? Same side interior is the oddball. Same side interior was supplementary. Everything else is congruent. And I think that's why I like that same side supplementary alliteration to help me remember which one's the oddball. Okay? So I want to prove this with you. Okay? When we prove this, the statement is going to be converted into our if-then statement. Our if-then statement is going to get converted into our given and prove statement. Remember, the given was the if, and the prove is the then. If I were to go back to that statement, it said if 2 parallel lines are intersected by a transversal, then alternate interior angles are congruent. Okay? This is kind of maybe the first time we've seen this. Okay? If we're going to take our hypothesis and make that our given, if I compare those 2 things I just highlighted, I would argue that the L parallel to M in my given says less than what the 2 parallel lines are intersected by a transversal statement would say. Does that make sense? Okay? Because when I see L parallel to M in my given, there is no discussion there about a transversal, right? I only see the transversal when I look at my picture. So what I want you guys to understand is that when we look at our picture is part of your given information. Does that make sense? Okay, it's provided for us. It's what we're going to use to work through this situation. So we do have this statement with our picture matching up our hypothesis. That means this here, change colors, that there should match up to our proof. But remember, we want to talk about specifics. So that's why instead of just random alternate interior angles in our proof statement, they write angle 4 congruent to angle 6. Okay? That's not the only set of alternate interior angles that we have up there. Okay? If we want to talk about that angle there and that angle there, that would be fine. We would just have to put a number here so we talk about that angle. Does that make sense? Okay? So, let's see what we can come up with here. All right, so the first thing we're going to do is we're going to write our given down. L is parallel to M. Given. Statement 2. Okay. Now here's the thing. Parallel is a vocabulary word. If I were to write that symbol out as a word, it's vocabulary. It's probably the last vocabulary word that we're going to encounter that really doesn't give me anything useful for my proof. Okay. Parallel, by definition, you have to say two coplanar lines that never intersect. Well, that doesn't give me anything that's going to be really nice for me to work out with in this proof. However, when we see the word parallel, some things should come to mind. After today, every time I see parallel, we should have 3 groupings of angles that we know to be congruent and 1 group of angles to be supplementary. Okay? Now, think about what we're trying to prove here. We're trying to prove that alternate interior angles are congruent. So I don't know that that's a fact yet. Does that make sense? So I can't use that. And I don't know that alternate exterior angles are congruent. That's a fact that we haven't gotten to yet. Okay? And I don't know that corresponding angles are congruent. But what was the postulate at the beginning? What was that truth that we started the section off with? It said, same side interior angles postulate. We know that to be a fact, right? Okay, we can't prove it, but we know that to be true. So if I come down here and you want to use that, which angles would be same side interior here? 3 and 6. So I'm going to say angle 3 and angle 6 are supplementary. We can use eventually, not congruent, supplementary. Eventually, after we've used this enough and we are all on the same page, if we want to write statement number 2, just say same side, supplementary, I'd be okay with that, okay? But I want to make sure that we understand that they're only supplementary because the lines that are forming those angles are first parallel, okay? That's the reason 3 and 6 are supplementary. Are there any other angles up there? Because this is something that should trigger, that statement hopefully triggers something else that we've done in the past. In the past, and I think we've had 3 or 4 proofs that were like this. If I came up with one set of angles that were supplementary, we would then look for a second set. Is there a second set of angles up there that are supplementary? And my hopes are now that we've been kind of in this class for over 30 days now. 4 and 3. Okay, that should be something that we recognize instantaneously. 4 and 3 are supplementary. Okay? Now the reason is because they're a what to one another? Good. They're a linear pair. So the linear pair postulate states that if two angles form a linear pair, then they're supplementary. Okay. Those two statements, 2 and 3, they should trigger something. They should trigger a thought that we've done this before. Okay? And what I'm going to argue to you guys is that if we think about what we've done in the past, we're basically done with this. It's just now cut and paste what we've done in the past. In the past, if we had two things that were supplementary, two sets of angles that are supplementary, didn't we then say that the measure of angle 3 plus the measure of angle 6 was equal to 180? Do you remember doing that? That's coming from this first statement up here. And that was because of that vocabulary. We knew what supplementary meant. The right definition of supplementary angle. Well, if I wrote that with 3 and 6, because it said they are supplementary, what can I write about 4 and 3? Same thing. Measure of angle 4 plus measure of angle 3 equals 180. It's going to be the same reason, so I'm just going to leave it all in statement number 4 here. Now I get to statement 5. And my hopes are that statement numbers 3, 4, the way 4 was written, kind of triggers a thought that we've seen in the past. Are those 180s the same? Is 180 always equal to 180? So then doesn't it make sense that the sums that make those 180s, don't those two things have to be the same? You guys remember doing that in other proofs? Okay, so we're going to write that measure of angle 3 plus the measure of angle 6 is equal to measure of angle 4 plus the measure of angle 3. You guys remember why? Still up there on the whiteboard on our left. We did it originally with equations. We said y, if those two y's were equal, y is 2x plus 3 and negative x plus 7 equal. We did a lot of it a couple days ago algebraically with systems of equations. These are equal. Why are these equal? Substitution. We've also said that in this case, the transitive property is viable. There's nothing wrong with using transitive if you want to. Okay, so that statement, because of what we've done in the past, should trigger a thought. We look at that and say, okay, I don't know what this sum over here is because I don't know what numbers are hidden behind these symbols. And I don't know what this sum is over here because I don't know what the numbers are that are hidden behind those symbols. But I do know a relationship. I do know a relationship between that symbol and the number hidden behind it, and that symbol and the number hidden behind it. What's that relationship? What do you know about measure of angle 3? They're the same, right? On the left-hand side, we've got that amount. And on the right-hand side, we've got that amount. So they cancel each other out algebraically, right? So when they cancel each other out, or I remove them from both sides, we've talked about that being subtraction. And now kind of the procedural step is if I've got two angles that have equal measures, aren't those angles going to be cut and paste images of one another? And I can basically say that they're congruent. So remember, that's the definition of congruency. And that step there matches up to what we set out to prove. Angle 6 congruent with angle 4, or angle 4 congruent with angle 6. And those were alternate interior, right? Okay? And proving the other theorems about alternate exterior or corresponding, it's a very similar approach. Okay? Now, if we, I don't know if I can do this because this thing's acting up funny. See if I can do this. Control C. I want to go back to chapter 2 real quick, and I want to go to our notes from 2.6. And I think it's actually maybe 2.5. Well, it might not have saved the way I wanted it to. Okay, so I paste what we just did next to this here. You see how these two things were both equal to 180. We had this subtraction thing. We had or substitution and subtraction and the definition of congruency. Are those steps there the same as what these were here? And that's when we were proving the congruent supplements theorem. I think if we scroll up, there was a vertical angle. Say, okay, we did do this a couple days ago. So I'm going to paste what we just did and shrink it a little bit. Give ourselves a little bit more room. Come on. Well, regardless, right there, you're seeing 3 different proofs for 3 different theorems, but the proof structure are identical, okay? And that's what I hope we recognize. People see proofs, and they work through algebraic proofs, and in other math classes they have proofs in them, and they think that every single one is different. They're not, okay? There's a lot of similarities, and what you learn in one will help you in the next. And what you learned in those 2 will help you in the third one, okay? But you can't use that if you don't retain what you learned in the first one and retain what you learned in the second one. Does that make sense? Okay? So I want to make sure that we're recognizing that. All right. We'll scroll down, skip over some stuff. You're going to see in your homework some problems that they start to add multiple parallel lines, multiple sets of parallel lines, and they start to ask you to find like measure of angle 1, measure of angle 2, and then 3, and then 4. And what a lot of people like to do initially, what is, in my opinion, a costly task or a procedure that creates issue, is if they look at this, and look, okay, they give me this 105, and I'm like, how do I find angle 1 right away? And guys, I don't know that you can find angle 1 right away. Okay? When you are asked, especially in Math Excel, they'll list, we want 8 answers. Maybe they're alphabetical, maybe here they're in order, like 1, 2, 3, whatever. You might not find angle 1 first. You might not be able to find angle 1 first. You might not be able to find angle A at first, or part B second, part C. That's just the way they're structuring the problem. Does that make sense? You might have to go through the entire problem, and you might have to find angle 8 first. I'm going to find angle 7 first. Does that make sense? Okay? So my argument, don't worry so much about what Math Excel is setting up for your template to answer your question. Go through this and see what you know. Find everything out that you know, and then once you think you've got enough, then start picking that stuff out of your picture to plug into your answers. Another thing you're going to find out, do they ask me what that angle right there is? Do they ask me what that angle or anything here that is blue? They don't ask me for those, right? But they might be paramount in regards to me being able to solve this problem. I might absolutely have to know all those blue angles to solve a particular problem. Okay? So they're not going to always tell you the things that you need or the parts that you need to find or the missing angles that you need to find as you work through problems. Okay? That's what, a lot of people struggle with early on, is trying to wrap their minds around that. My suggestion to you, I'm going to pick out 2 parallel lines. I'll pick out P and Q. And I'm going to visually remove everything else that isn't really an issue. I don't want to deal with it at this moment. Does this look just like the picture that we've been working with yesterday and today? And if those are parallel, because we've got these markings, right? I know if those are congruent because they're vertical. What are these two angles? What's angle 3 going to be? Is it alternate interior with 105? Well, angle 3 has got to be 105. What's angle 5 got to be? 105. Now, I don't know if I'm going to need these, but I can absolutely tell that that's got to be 75. That's got to be 75. That's got to be 75. And that's got to be 75. Does that make sense? Okay. Once I've got those, and I know it's easier for me because I've got the ability to, cover these up and then sometimes come back and erase them. Okay. And that's not as easy for you guys on your paper, okay, or your computer screen. But if you've got to redraw a picture several times, that's fine. That's what's necessary. So now I'm going to cover this stuff up. Does that picture have two parallel lines cut by transversal? What's angle 2 going to be? 75, right? Angle 8 is going to be 105. This angle here that's blank is going to be 105, and angle 1, 75, right? And then I'm going to uncover that, and now maybe I cover this stuff back up. And does that allow me to find these remaining angles down here at the bottom? It should be 75, 105, 105, 75, right? And then when I'm done, I now have all the angles up there, and I have measurements for the ones that they were asking for, 1 through 8. Now, I've got some extras up there, which is great. That's fine. Okay, another problem is maybe you need all of them. But people will look at a complex picture and try to just deal with that entire complex picture at one time. Try to remove parts that are unnecessary. Okay? I've got a couple more here, and we're just going to set the algebra up. Okay, so we'll do the geometry, and I'll let you do the algebra by yourself a little bit. But this is what kind of shape is that? Anybody know? Quadrilateral that has one set of parallel sides. Starts with a T. Trapezoid, good. Okay, so we got trapezoid here. When I look at trapezoid, parallel lines, those jump off the page every single time from now on out. Every time that you see a shape that has parallel lines, what you want to think is parallel lines intersected by a transversal. Because right now I've got parallel lines intersected by a transversal. What I'm going to do is I'm going to extend that parallel line. I'm going to extend that parallel line. And I'm going to look at that thing right there. And if I do that, so extending those things and using red just kind of draws my attention to that stuff, and I was able to maybe visually neglect that other line that I erased. Does that look like the picture we've been dealing with? And what types of angles are 2x and x minus 12 that they're talking about here? Those two angles there are same side interior, aren't they? So if the same side interior, what's that relationship? Careful. Not congruent. Same side, supplementary. So I'm going to take 2x plus x minus 12 and get 180, right? And once I have that relationship, also I can solve for that. I'm going to go back then to my original problem and think, well, don't I have a similar thing going on right here? Like extend those. Is that the picture we've been working on? And 3y and y plus 20, or what's going on? Supplementary again, good. Same side interior. My thought is, guys, when something is difficult, I think looking at that picture off the bat, that might be confusing. Well, what do I relate? Do I take 2x and compare it to 3y? Do I take 2x, compare it with x minus 12? 2x, compare it with y plus 20? Which one do I know to be true? A true comparison. So if I can make the picture a little bit simpler, maybe one of my relationships will jump off the page to me. Okay? What about this one here? Okay, we've got a triangle. And we'll actually spend a lot of time on this triangle here, where we take one of the sides and make it parallel to the third side. Or take one of the sides and make a third line, or fourth line, I guess in this case, parallel to that side. So we'll add this thing in here in the middle. So this might be like a confusing looking picture. I don't know what to do. But I know that this angle here isn't doing any good for me. I don't even know what it is. This angle here is no good. That angle there is no good. That line there is probably no good. And I get this. What if I extend that parallel line, that parallel line? There's my transversal, right? Does that make sense? Okay. And now I also knew to maybe erase the things that I did because of them providing me expressions for those angles that have 3x. Obviously, I don't want to erase the 3x minus 10 angle, right? Okay. So if I look at those two angles, what is the relationship between that angle there and that angle there? They're corresponding. Good. Okay, so we can name them based off of their definition, right? Okay. And then if they're corresponding, what was the relationship about corresponding angles that today's theorem told us? Corresponding angles are congruent. So we set up that equation. Okay, and I'll let you guys, as we start going through some of these relationships, if I think the algebra is something we should be able to do, I'll just leave that for you guys to do. We'll set up the equation initially, and you guys can finish that algebra. Okay. Does this stuff make sense? Okay. What has to happen, though, in order for the corresponding angles to be congruent, alternate interior or alternate exterior angles to be congruent, or same side interior angles to be supplementary, what is the number one thing that has to be going on with our lines? They have to be parallel. Okay. If they're not parallel, you cannot make those conclusions. Okay? There's an assignment in Math Excel. We'll talk about that. We'll spend a couple days on this stuff, guys. This is a very important thing for the end of course exam. It's very important as we move on through the other topics in the textbook. So it might seem like we spend maybe 2, 3, 4 days on this stuff.